All right, why don't we get started? Again, I'm going to ask everybody to remain muted. We are recording this. Please put your questions into the chat, and we will get to them at the end. I'm going to speak briefly. I'm Fred McHugh. I'm the Director of Virtualization Cloud and Automation Services here at WEI. And with me is one of my principal architects, Daniel. And
Hi.
today we're going to be talking about, and this is a new series for us that we decided to go through this year. We get a lot of questions from folks out in the field. People are where infrastructure as code and other technologies are really becoming critical for IT organizations, not just development. People are asking us, where do we get started? So Daniel and I sat down and we're like, where do we start? Let's start from the beginning, because I think for myself, having been in a lot of folks' shoes, I was in in-house IT for a long time. Some of these things, where do I even begin? Where do I even go with this? So we have this is the first in our series that we hope to conduct about every other month, and we're going to start with Git, which we find is a critical fundamental technology. So again, I'm Fred, and I'm with Daniel. All right, Daniel, why don't you go to the next slide?
All right.
And not to bore everybody, I will briefly talk about WEI. Most of you know us as you're already customers of ours. We have been around since 1989. We are minority led, so we can do a lot of your spend in minority. I think the big thing that I want to convey to you guys is that we have, we kind of handle pretty much every stack of technology today, right? Cloud, hybrid cloud. And we're seeing that the DevOps space is really bleeding into that whole world where infrastructure of code has become critical. Certain technologies like Kubernetes is really only administered in code. So, you just kind of see it as a Venn diagram. And that's what we want to kind of convey to you, is that we are here to help. We understand that these problems are really complex and might touch a lot of different technologies. So, that's what we've been focusing on. And here's our awards and patting ourselves on the back, some of our customers. All right, Daniel, go next. So these are our core technologies. I think some of these, like I said, the way to think of us, hybrid cloud, on-prem, in the public cloud, and how to make those work together, what technologies you might need to do both of those. We have a very large networking and networking security practice run by my counterpart, Brian Jakes. You guys might know him. But really, we're here to do solution design, implementation, architecture, consulting at almost every level, right? We can have those conversations with you, work through it, things in cloud, would start getting into cost management, best practices, well-architected reviews. These are all services that we can to do for you. One of the new ones that I am personally responsible for is our end user computing business, which has really started taking off. We've gotten into mobile device management. Some of you might know that might already buy your devices from us, but we have managed services around Workspace ONE or Intune, Autopilot. If you're looking at that kind of stuff, we definitely can help you with that. And some of our differentiators, really stuff like this, we try to help people with training, and this is stuff that we can tailor to your company. If you have questions and you want Daniel to come in and work with you, even if it's in just an education capacity, that's something we can do for you, right? Let us come in and talk about your specific problems. As I said earlier, here are the pillars of our technologies. Pretty straightforward. I focus on the data center, enterprise mobility, and DevOps and automation and cloud. To me, the DevOps automation for us is really the glue that makes a lot of this stuff work, right? So when we talk about some of these complex things, as I said earlier, a lot of times we need sticky little pieces to make this stuff talk to each other. And that's where the infrastructure as code or some of these things can come in. And that's where we find we provide the most value, right? So it's not just doing the basic installation architecture. It's really the messy problems that nobody wants to deal with. That's kind of what we specialize in. And project management, again, is one of our key components. And so this slide is talking about some of the key people on my team. And again, this is what I want to show, that we have people who are experts in every piece, and we work together. We're very collaborative here at WEI in the way we do things. And so when you have a complex problem, we can bring the right people to it. It's not just, while we have some generalists, we have a lot of specialists. And I think that's what's a big differentiator for us. We're partners with all the leading OEMs, of course. We work with them all very closely. If you're looking at Kubernetes, if you're looking at OpenShift, if you're looking at Tanzu, we're a big Nutanix partner, cloud partners. And we have some of those advanced certifications. Well, certifications aren't the end all be all. We do try to maintain them as for partner levels, as well as just showing that we do have that expertise. And with that, I am going to hand it over to Daniel, who is going to be leading this to Review Day. Thank you.
All right. Let's make sure we get everybody out of the waiting room. Um, all right. Hi, welcome. Thank you so much for coming. This is the first time I've done one of these. So hopefully I don't stumble over my words too much. A little nervous, but very excited to have you guys join me today. So yeah, as Fred said, we're talking about Git today for systems admins. This is the first in our series, DevOps for SysOps. Um, And let me tell you a little bit about myself. So currently I work at WEI. I'm a DevOps solutions architect. I have experience about almost 15 years working in Kubernetes, DevOps, cloud. I was a senior platform engineer for a very large online retailer. Did some work for the Air Force. I worked at Autodesk, which for anyone who doesn't know Autodesk, they're a Silicon Valley company. They're very big in 3D modeling. So 3D modeling for architecture, like skyscrapers, for manufacturing, and they're the leader in visual effects. So like they have their hands in every movie that you've seen. And I had some great experiences working internationally with colleagues in Eastern Europe and in Asia. And it was a really fun time, especially when I was at Autodesk, because I would sort of just wake up in Europe and then follow the sun to the other side of the world. So yeah, working across many time zones, I've got a good amount of experience doing that. So certifications, this is to talk about a little bit more of my in-depth interests. Recently, I got an Azure AI Fundamentals certification, working on a NVIDIA AI cert. Just to let you know that that's some of my interests that I'm getting deeper into. Uh, have a Security Plus certification, so I have an interest in that as well. And I have a certification in AWS, like I mentioned before. I have a lot of experience kind of just only working in the cloud. Um, and uh, and I'm expanding that to GCP as well. So moving on, DevOps for SysOps series, right? This is Git for SysOps, system admins. This is our first talk, bringing DevOps practices to SysOps. Now, when I say SysOps, I mean system operations, right? Practice for managing computer systems, servers, networks, and other IT infrastructure, right? IT people. I used to be an IT person, and I just sort of slowly blended into a little bit more developer stuff. So for me, when I say SysOps, DevOps, I don't really like in my mind, from my experience, and they're almost one and the same, or maybe they should be, or maybe we're growing, uh, one set of skills into another. But I see that a lot of acronyms sometimes start saying the same things, right? So there's a little, but just to clarify those, I'll have these definitions later up as well. So DevOps world. Here's the DevOps world, well, at least a glimpse of it. Maybe some of you have seen this before. It's meant to be intimidating. DevOps is a big, big subject, and there's no way that anybody can be expected to know all of these different products here. I certainly don't. But don't worry. Hold up. Today we're just talking about Git. So here's an overview of what we're going to go through today. So why Git? So Git is a free open source distributed SCM, source control management tool. What is an SCM? So source control management, the practice of managing changes to source files over time, also called version control. Uh, Git is really the foundational technology for DevOps practices. There are other source control tools out there, but Git really took over about 14 years ago, and there's no signs of it slowing down. So Git enables transformational engineering strategies like configuration as code, which we alluded to earlier on, uh, and then can get you to something that people are calling GitOps now. So configuration as code, for those of you who might be hearing this for the first time, this is a practice of defining your system settings as code. Instead of manually configuring them through the UI, you can write it all down in something like a YAML file and then check that into source code and track those changes. Really helps to prevent those fat finger moments and helps with disaster recovery. Other tools like Ansible are also configuration as code. And so GitOps is a DevOps practice that focuses on using Git as the driver of automation, right? It tries to leverage Git as being the source of truth, right? If it doesn't exist in Git, it shouldn't exist in production. That's basically the idea. And when you leverage uh, Git as a source of truth, you can start doing cool things like self-healing for systems and more. All right, so let's talk about the history of Git very quickly. Well, it was created by the famous Linus Torvalds in 2005. He used it for development on the Linux kernel itself. And yeah, some people know that he named Linux and Git both after himself. So let's talk about how we use Git. So our system admin sysops Git scenarios. We'll start at the most base level of how to use Git, local Git development. So here you are, the red sysops user 1 on your workstation. You've just installed Git, you've opened up a new repository, and you're given this thing called the main branch. You start working on a PowerShell script, and then you can commit it to your main branch. Once you commit it, that's basically version 1. Well, it's not best practice to commit directly to the main branch. So now you can take it a level further, and you can create a development branch where you can isolate your working changes. You start working on version 2, and you commit that, but you don't commit it directly to that main branch. You commit it to your development branch. And then when you're satisfied with the changes that you've been developing, you can then merge those back into the main branch. That's sort of like where all of your production code might live, right? Everything that's ready for prime time, people expect to find working code in the main branch. Whereas in a development code, it's a safe place to fail quickly and fail safely. Use case number 2, distributed collaboration, also known as teamwork. So how do we get other people involved in Git? So here's where we left off. We got version 2 checked into the main branch of our PowerShell script. Well, now we introduce a centralized repository for Git. GitHub, you might have heard of it. So this isn't on your laptop, this is in the cloud. And here's user 2, your colleague across the hall. And they want to know what you're working on. They want to pull your recent changes. And so notice that when they pull, they didn't just get your file, the latest version of your file, they actually got the history as well. And that's because when they did a pull on the repository, they got actually all of the information in the repository, not just the files. So they want to contribute to your code. They create their own branch so as not to mess up what's already been approved. They commit their version 3 to their own branch. And then again, they can merge it back into the main branch. And then you can pull those changes as well. And now you have them. Okay. Now let's take it one step further. How can we do this a little bit better? Use case 2.5, code review. This is the good stuff. So let's rewind our scenario a little bit. Okay. Our second developer, our second IT person, whatever name you want to give them, they haven't merged their code back into the main branch, but they just committed it to their own development branch. Now, instead of just merging it into the main branch, they're going to do some extra validation on the changes. They're going to open a code review. This is a space where other colleagues can give their input, review the code changes before anything goes into production. And it's literally a back and forth discussion. Uh, Anybody who's brought into the code review, they can comment on single lines of code even, or entire files, or the entire group of files that you've put into the code review. Once those changes are approved, they can then be merged into the main branch again. Okay, so now that we got out of those scenarios, let's dive a little bit deeper into the advantages of Git. So let's say that you have to update 603 switches. Using Git, you can back up your scripts and notes for disaster recovery, right? So if your laptop goes down, well, good thing that it's checked into source code. Other people likely have a copy of that. And if they don't, if you're using something like GitHub, that central repository is an off-site safe place for disaster recovery. You can collaborate with peers, define your hardware configurations as code, and you can version and track your updates. Something else you can do is that this is another big feature about Git, especially for the open source community. So imagine that rather than writing your own Ansible script from scratch, you decide to copy and modify an existing project. And this could be something else out on the internet, or it could be something that you've already previously worked on, or that another colleague has previously worked on. So you can pick up from where somebody else left off. So you could clone that repository, or you could fork. Forking is a different way of sort of uh, you can imagine that you make a branch off of different branches in the repository. A fork is like you create a repository copy and name it something different, right? You can create development branches that we talked about, quickly test and revert your changes, and dump them too if they don't work out. And then, of course, code reviews. You can pull those in. And did I mention working offline? Right. So GitHub is great for um, GitHub offers a lot as a central repository. However, sometimes you don't have internet access. But with Git, you have your entire repository locally on your computer. You don't need internet access. You will once you want to send them back up to the cloud for code reviews, though. All right, so let's talk about some real world examples. Cross-team collaboration. So let's say that you're tasked with updating 603 switches. You and the security team each own part of the update script. So now we're talking about different parts of the company trying to work on the same project. Um, you can imagine that this update script will need multiple sign-offs before it goes into production. So using Git, you'll share work with your colleagues. You'll work in parallel. You'll ask for code reviews, and you'll restrict code from being merged into production prematurely. So let's see what that looks like. So here we have the sysadmin in red, the security team in blue. We have the main branch in version 1 of our update script. So Sysadmin will create their own branch and start adding their own and start committing their own code. The security team can pick up from where the sysadmin started and actually branch from their branch. They'll add their changes. And obviously, you're still working at the same time. When the security team is ready, they'll open up a code review. And then you can pull the security team's changes into your branch and see them together. And then again, both of you can collaborate in another code review before merging everything back into the main branch for production. So even though this is version 2, there was a lot of work that went into version 2. So let's talk about some of the architecture and key concepts of Git that sort of make it special. So unique identifiers. Git is based on unique identifiers called hashes. So they create a unique reference hash value for various objects in the repositories. A blob is what they call it. It's a file. It gets a hash. A tree, a directory. It gets a hash too. And then a commit, which is a change to the repository, that gets its own hash as well. Over here on the right, you can see this is kind of what hashes look like. It's a big, long character that isn't very good for human readability, but the computers understand it well enough. So what do the values give us? It gives us a lot in terms of data integrity. So the content of the object is actually what calculates the hash value. So that means that a change to the object results in a change to the hash value. And this helps detect any tampering or corruption. So what does a commit look like? What does a hash look like in the wild? So this is a real set of commits, commit history from a repository. So I wanted to point out that they're connected in a chain. So this is how we get some of our histories linked together. So I'll back up a second here. You can see in each commit, there's actually 2 hash values at the top of each commit. The one on the right here is called the parent. Now you don't have to memorize the whole long chain. Just note that the first couple of characters, D3E2, 2F. In the previous one, in the previous commit, we see that same commit there. So this is what's called a parent-child relationship. The hash on the right is the parent, and the hash on the left is called the child. But you can start to see, if you want to look through on your own, that each commit is linked to the previous one in this form. So let's review the workflow for Git. So a developer, now don't be thrown off by the term developer, right? I see anybody who's going to write any type of technical files and put them into Git. They're all developers in my eyes. So don't be turned off by titles. So let's say that the developer, the IT admin, whoever's working on a switch configuration file, right? They'll clone a repository. They'll create a branch to work in. Again, a branch is a safe place to make your changes. They'll make several updates in the form of commits on that configuration file. And then they'll request a code review, inviting in their colleagues to review, have a discussion about what changes are being made. And then they will merge or close the code review. And I want to emphasize on this close part. Close doesn't just mean, oh, it got merged in. Sometimes you start a project working in a branch and you test it, only to find out, oh, we didn't really want to do this. It's perfectly okay to trash the branch and it never gets merged back in. That's okay. That's all about this philosophy of failing fast, failing quickly, failing safely. Um, that's a big part of the Git workflow that, especially in the open source community, they really appreciate. So, best practices for Git and some modern development. So, best practices for Git are to commit your work frequently. Like, remember those days when before automatic saves, we would just have our hand on the keyboard and just sort of as almost a twitch, Command S, right? Control S, right? To just save, 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 save. Think about it like that. Yeah, that's what you should be doing with your work. Anytime you write even just one line of code and you say, okay, I think I'm going to keep this right, commit that change. Commit that change so that you don't lose it. Um, Write descriptive commit messages. All right. It's good to write notes for yourself, even if you don't think anybody else is gonna look at your code. Um, Descriptive messages that say, "Hey, what was in this commit? What did I update? I updated a specific line. I updated a specific file." Uh, it's a lot easier to read the commit messages than to go through lines and lines of code and histories of code changes. So make it easy for yourself, make it easier for other people to see what work has been done. Use branches for testing and developing new features. And do not commit directly to the main branch. Production should be thought of as a sacred space. Collaborate. Don't be afraid to collaborate and leverage code reviews. Um, Furthermore, in DevOps, there's a practice called a blameless review, where culturally, DevOps is trying to emphasize, hey, we get better when we talk honestly about problems, mistakes that happened, and we're not looking to blame people. We're looking to tear apart the process that happened that maybe introduced bad changes so that we can figure it out. So I understand it can be totally uh, nerve-wracking to put yourself out there and say, okay, everybody, tell me my code is bad, but you'll be better for it. And even if some people are rude about it, well, you'll have a history of that in writing. So, also part of collaboration is reuse existing code. It's okay to steal others' ideas. Definitely GitHub is built around that. So modern development. So how are some big companies using Git and DevOps practices? So the largest companies are using Git, DevOps, CI/CD practices to deploy updates at incredible speeds. And this is largely accomplished by releasing much smaller changes more frequently. So maybe some of you, maybe this is old news for some of you, but Amazon releases new features and updates to its e-commerce platform multiple times a day. Netflix pushes changes to its streaming platform rapidly while ensuring a seamless experience for its users. Uh, if they pushed all of their changes over the past week or month, we would notice it, right? Uh, we would say, "Hey, geez, everything looks different." But largely, they just push little bit by little bit, and our experience feels uninterrupted. And Alphabet, Google, I mean, they really drove this part of the industry to release faster. So their daily updates for search, Gmail, cloud services, they go unnoticed by most users. If you search somewhere on the page, you might see a version number, and if you find it, it might be an interesting experiment to just sort of maybe for even just a day, see if that number changes or see how many times it changes. Um, yeah, they're releasing a lot of changes very frequently, multiple times a day. That is what they call continuous deployment. The CI part of things, a lot of companies can get that. The CD part, the continuous delivery, multiple deployments a day, uh, we all strive for it, but only a few companies like Amazon, Netflix, and Google have really been able to put that into practice. So some popular centralized repository services are GitHub and GitLab. There are some others, but these are really popular. And I'd recommend either one of them, especially because they've introduced, or I should say, they've integrated many more tools into the Git experience, into the Git workflow. Some of that you could call GitOps. Others, it's just convenient to have things like your automation pipelines not only defined in code, but running on the same platform. Um, we can do a live demo, by the way. I'm prepared to do that. I want to get to the questions, and at that point, if you guys say, "Yeah, yeah, yeah, give me a demo," right? Then we can jump back to this. So, I want to give an opportunity to review some of the definitions that we went through. So, I'll leave this up for a bit. I know it's a lot to read. But so DevOps is development operations or developer operations. This is a big set of practices that spans a lot of different technologies. Basically, as a DevOps engineer, you're expected to know everything, everything about software. System operations, SysOps. Uh, this is more of traditionally thought of as IT infrastructure. SCM, source control management or version control. Git, this is a free and open source distributed SCM software. And maybe I didn't make it clear. I want to take another moment. GitHub and GitLab are not Git. They are software as a service platforms that use Git, if that wasn't clear before. So GitOps, again, that's Git operations. It's a DevOps practice that focuses on Git as the driver of automation for leveraging strategies like self-healing and more. CAC, configuration as code. This is tools like Ansible. Uh, really, any config file could be configuration as code if you're checking it into your source control. There's another similar term called infrastructure as code. Very similar to Ansible. You might have heard of a tool called Terraform. The biggest difference is that Ansible can run really on just about anything. Terraform is really for just provisioning and managing cloud infrastructure. I haven't gone through every single provider that it supports, but it's largely just sort of used for spinning up all the different services and defining all of the services and their configurations for platforms like AWS, Azure, Google Cloud, and others like that. CI/CD stands for continuous integration and continuous delivery or continuous deployment. The CI part is about frequently merging code changes to a central repository and triggering automated processes to package and review that code. The CD portion is about delivering that code. So code changes are automatically prepared, tested, and then this is the hardest part, deployed to production. So to do that multiple times a day, that final deployment, that's the hard part for people. But we can get there. All right, so I want to open it up to questions. We'll see what's going on in the chat. Fred, I don't know if you've teed up any questions yet. if you've been.
Yeah, so we have two. So the first one is from Nicholas. What's the difference between reusing code versus plagiarism? Can you get any legal trouble for, reusing code?
Yes, yes. Good question. So, there's a number of different software licenses. The MIT license is a popular one that you'll see out there. Something that admittedly I need to educate myself more on. There's a lot of code out there that says fooey with all the legalese there. I'm putting it up on GitHub publicly, knowing that people are knowing and encouraging for other people to copy. So that's largely I have never heard of anybody saying, "Hey, I put my code out in the public. Somebody else used it, and now I'm starting a lawsuit," right?
So,
If
so why
you
don't why don't you touch on the public versus private repositories like in
Oh,
GitHub and what that means so people don't
excellent.
know?
Yeah. So GitHub, right? Or GitLab, uh, you can use their service right now for free, but your nothing's really free. What you're selling is that when you take the free access, your repository is going to be open on the internet for anybody to search and copy. You can pay for making those repositories private and keep them protected. There are still licenses that you probably want to investigate if you want to say, hey, look, I want to copyright my source code and make sure that nobody else can use it. Uh, but that's a whole line of legalese that I admittedly need more education myself in. But yeah, if you're not going to copyright it, then and you're going to put it out in the public, don't be surprised that other people use it. Hopefully that answered your question, Nicholas. Feel free to ask a follow-up question.
But I think I want to add to that, typically we recommend to people most everything's been written. When we use that example of, switch updates, that's stuff that we do here today, right? If we have to update a bunch of switches, we're not going to do that by hand. So a lot of that code is pretty shareable. People understand, especially if you're working in Ansible or Terraform. They have what's called providers, as Daniel alluded to, where they sort of put the framework around it. So it's all pretty much everybody's sort of sharing a lot of the basic stuff, and there isn't a ton of proprietary stuff from the infrastructure as code or configuration as code. Obviously, you don't want to share IP addresses, all that stuff, and we could get into the kind of deep into secrets and all that stuff. That's a totally different conversation we're having. But generally, a lot of this stuff is pre-written, and when you do things like Ansible, for example, why would I buy Red Hat's version if it's free? Well, the reason why you can buy from Red Hat is that they pre-write everything for you. So they have the providers and they have a lot of the examples pre-written, so you're not starting from scratch. So that's a big one.
Mhm.
There's a couple more. Daniel. Are there any AI tools for Git that can help with reuse of code or code reviews?
So yeah, AI tools. So I should mention that so Microsoft actually owns GitHub, and uh, their AI, Microsoft has branded basically all of their AI experience Copilot, but I want to make a distinction is that they originally actually came out with a tool for GitHub to help people write code, and it was called Copilot. All right. They then branded everything Copilot, and if you Google that right now, you'll see something that looks like a chatbot service. So I wanted to make a clear distinction that Copilot for GitHub is not so much a chat bot. It actually, as you are writing in your developer environment, um, the AI is actually looking at your own source code. It is also referencing some other source code that it's been trained with, and it will it, it it'll give you automatic suggestions, almost like just sort of what do we call it? Almost like just like when you're typing something and you have like autocomplete, right? Um, it's like that, but on a much larger scale because you'll get these big blocks of code generated. It still requires a developer to have some sense about them, right? And not just accept every suggestion that the AI gives you. Um, but it's sort of reusing code because it's read all the code that it's been given and it's repurposing it for you. Um, if you want a different if you want a different experience than sort of code completion assistance, there are a lot of AI tools that uh, can help you search the knowledge bases that are out there, um, and give you citations to articles that have already been written up on like Stack Overflow or something like that. I hope that that answered your question. Feel free to follow up if you want me to kind of dig into a different direction.
And the last question I have in the chat is, and I know the answer to this, is there any malware validation done on uploaded code?
Uh, yes, not by default. So one of the you might recall that I mentioned, oh, GitLab and GitHub, not only do they offer the benefits of having a central repository, they've integrated a lot of other tools. So you have to be proactive uh, in enabling these services, but there's a lot of what we call shift left security that can be automatically triggered as soon as you open a code review or push any code up there. Um, but the specifically looking for malware, what has been done for a while is in your CI pipelines, your continuous integration pipelines, those are just a string of automation for whatever you want. And so what has been happening is that, oh, okay, when people merge something, or actually, this is an advanced feature that I'll be excited to talk about in a subsequent uh, presentation. Um, when you open up a code review, you can actually set rules on the code review that say, hey, I don't, even if everybody approves this, it is blocked from being merged into main until it passes certain validation tests, right? So these are CI pipelines that will, I mean, some of them are tests just for user experience tests, they're unit tests, but they're also malware tests. So they'll literally be scanned by any tool you want, Sneak, uh, or yeah, anything that you want to scan your code with. There's a lot of options out there. Um, but the shift left security part, there's a number of different strategies that you can try to leverage where it'll actually try to correct you before you even open up the code review. And those are actively in development on GitHub and GitLab, so expect to see a lot more about that. All right. Anyone else?
And yeah, if anybody wants to get off mute and ask a question, or if not, I think we should do the demo, Daniel. I think it really ties a lot of the
All right.
stuff together. I think if you run through your exercise, this is pretty quick because we have about 14 minutes left, so I think we should be able just to kind of squeeze this in
Okay. I think I'm gonna have
so
to
you guys can
start.
see how all this comes together.
I'm gonna have to change my presentation modes here. Okay. Okay. And okay. Let me make sure I'm sharing again.
Nope, not yet.
Okay. Can you see me again?
Yep, all good.
Okay. So here I am in GitHub. Okay. I just have this. So there's different concepts here. This is an organization, just self-named, and I have a repository here called Git Basics POC. I can have a bunch of different repositories here, whole long list of them. right? So this is one of many. So in this one, uh, you can actually, so you'd usually come in here to just sort of do a copy, right, and pull and do what's called a git clone command, just to pull the entire repository down to your local workstation. But we can actually do work right here in the web interface. So yeah, let's just say let's see, I got just some text file here. Can edit it. Just kind of makes just sort of a nonsense change. Um, I can commit my changes, right? I have different options here. I can commit directly to the main branch. Well, that's not a good idea, right? I should create a new branch, right? And by the way, you can lock it down so that nobody can commit to the main branch ever, that they have to go through a code review. Okay, so see now I have my now what's happened is that it's trying to open what's called a pull request. Now, you've heard me say code review because that's the vendor agnostic term. In GitHub, they call it a pull request. In GitLab, they call it a merge request. On other Git platforms, they might call it something else, but it's a code review. So again, I just the code review has its title, has a description. Did you notice that? It would, while it was orange, it said checking availability to merge. It's in this section that you can add uh, different pieces of automation to run malware scans, to run unit tests and other kinds of tests. So you can add other kinds of rules as well to lock down merging to production. And I don't have anybody else in here, but so I'm gonna have to self-approve my own pull request. That's not a good practice. You know, you want to have somebody else signing off. Uh, you could also close it, right? You could also say, "Oh, I'm ditching my changes. I'm closing it." But uh, I want to stress that even though I'm working by myself here, there's a growing list of rules that you can lock down for your entire organization or just a repository um, that can customize your rules for merging code back into main. So here I'm going to have to just merge my own. Ask me again if I want to confirm that. It's merged now, and I can clean up, delete the branch when I'm done. So if we go back to the main branch here, should have pointed out, you can view all your branches here and switch between them. Let's see, can I see the old ones? Oh, I just deleted it. I should have kept it around. I would have been able to move to it. But in any case, I can go back to the main branch and I can look at all the commits. I can look at the whole history of what's happened. Notice that there's a short version of the hash here for each commit. And so that makes it easy to find a commit in history and make sure that you're talking about not just what something was named, right? Because we can imagine that in our uh, in how we name our commits, we might start saying things that sound or are exactly the same. Updated blah 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 file, right? Added unit test, right? But these hashes will always keep them unique. So we can see throughout time different commits that I made. Right? We can open it up. We can open it up directly at that commit. We can see some changes. Oh, okay. This file looks like it was added. Some text was added to the README. And it's worth noting that you can actually, just as you can create a new branch, you can create a branch off of a specific commit hash. Let's see if I can do that easily in the UI. If you're doing all of this on the command line, which I really stress, if you're afraid of terminal, there's only a few commands to know with Git, and it's very easy to learn, uh, at least just the Git commands, and it really does make your life pretty easy. So don't be afraid if that's a skill that you haven't gotten into yet. Let's see. View all branches. Maybe I can create a new branch. It's really a lot easier to do it from source code here. So this is my developer experience working locally. Let's see. So this is a Microsoft product. There's other developer environments out there. This is Visual Studio Code. I like being able to have my terminal just down here. Ooh, actually, I just realized, but let's do.
Which I think is important because I learned this a couple years ago. There's a lot of integrated development environments. If you're using, Visual Studio or PyCharm or something, that integrates directly with Git too, right? So you can put in your repositories and stuff and have it just a checkbox like pull, push, commit. All you don't have to come into the website every single time. Well, a lot of the tools have these features. You just add your account, you add your login, and you add the stuff, and you can do it right from whatever environment you're developing in.
Right, right. Now, so I have a list of each one of these directories is a different repository, right? Here's an example of disaster recovery. Git basics POC. Oops, I just deleted the whole thing. Okay, but you just grab that URL. Simple command: git clone, and now it's back. And yeah, so to make a branch, it says easy as moving into that repo. So change your directory CD into git basics. All right, we're on the main branch, right? You can say git branch. I believe it's -B because I have to create a new one, and we'll just call it new. I'll call it branch 2.
Hey, I hate to bother you, but I think you're trying to share your Visual Studio Code and you're not.
Oh my gosh, I'm not?
No, you are not.
Alex, thank you so much. I am. Why does it say it is paused? Okay, let me try this again. Okay. Share my screen again. How about now?
We can see it now.
Yeah.
Okay, great. Okay, so yeah, maybe I should redo that. So what I was showing is that for disaster recovery purposes, right? Here's my repository, Git basics, right? Oops, I deleted it, right? Simple command, git clone. All right, and I can pull it back. Sure. Sometimes Visual Studio Code does not update it very well, but let's try this again. Okay. Visual Studio Code has its own issues sometimes. Uh, Git clone. Okay, here it is, back. All right, so I just deleted it, but I was able to pull it back down from the central repository. Git basics, git branch. Okay, git branch. I think it's list. You can see we have two different branches there. When I say list, we have main and branch 2. Git checkout is how you change branches. Now you can see the context has changed. Git branch 2. I could, yeah, change a file, add a file, delete a file. Oh yeah, it's probably worth noting that, so here I obviously have a PNG file. It is not recommended that you store binaries in Git. Git has tried to do something like that in the past. They've tried to integrate that type of support in the past. And same with large files. They had, I think Git LFS, large file store, still exists for GitHub. It's not widely used, not widely loved. There are other repositories for media files, binary files, code that's been compiled. Artifactory is a very popular one. Nexus is another popular one. Um, those are better solutions for storing those types of files. But for making a website, yeah, I don't see any problem with putting in a number of JPEG files, PNG files. You can certainly use images to an extent. And if you're going, yeah, so don't be afraid to put some media in there. Don't put video up there. You want to put up a GIF? Sure, that'll work. Yeah.
So we're at 1 o'clock. So at the end of our presentation here, we still have quite a few folks on. Can you put up that last slide, Daniel, just to close out?
Yeah.
So if you guys have any questions, if you want to talk to Daniel about any of this stuff, if you still aren't quite sure, maybe you have some Ansible scripts sitting around and you're like, maybe we should start organizing this. You can reach out to your sales team. They can get you in touch. We can set up a meeting. Also, Daniel's information is in the slide deck with the video. Kathy just confirmed that she'll be sending out both the video and the slide deck. You should see that in the next day or so. So that's it. If nobody has more questions.
I want to make sure everybody can see
Go back one.
this last slide. Do we still see it, Fred?
Yep, we're good.
Okay, good. Okay. So yeah, feel free to reach out to me on LinkedIn for any questions, or you can contact your sales rep. Yeah, we're eager to, me specifically, I'm eager to talk to you about AI, custom copilots, if that's something that you want to leverage for your company. I want to talk about all things DevOps, CI/CD, Kubernetes, Terraform, Ansible, and many others. Cloud and hybrid cloud strategies. So,
And
yeah,
the next
I
in
got
the
my email
series,
here and LinkedIn. There's not too many people with the last name Perinas, so you'll find me pretty easily, I think.
And the next in the series, we're going to be building off of this and getting into some of the basics of infrastructure as code. So that'll probably be a little over a month from now. So we'll be building on this with some basics around what YAML is, how do we use it, what are the basics of Ansible and Terraform, and how do we get into that and integrating it with Git and why we need Git, because we're going to start writing some code. So hopefully you guys can join us in a couple months for the next in the series.
Yeah.
Thank you.
Thanks for coming.